So we're going to try to do some real-time AI editing with a human at the wheel. This is going to I knew this when we started with this that I would make up some questions, and then I would see you guys speak and see your panels, and I want to just throw out the questions. So I'm not going to do that all together, but I will do some editing and adjusting. You've met our panelists, I believe. So one of the things you don't want to have, in my experience, is a solution looking for a problem. So we're here, confidential computing. So that suggests there's the opposite of that. There's data leaks, there's problems. And I want to just ask the panel generally, of the problems that you associate with AI right now, where are the threats seeming to be most real, and as opposed to sort of like hypothetical issues? I'm going to start with Mark.
Well, actually, I think the threats right now with AI, speaking of agentic systems, are risks of prompt injection and information flows that might violate the policy of the owner of the agent. And by that I mean, and some of you might have seen what happened with GitHub MCP last week, which was leaking information from a private repo into a public one through a prompt injection. So combination of both of those. I think that's the biggest risk right now with agentic systems, is we don't have a good handle on information flow.
Mm-hmm. And is that a place where a well-designed, trusted execution environment or something could have helped?
Well, I think they're somewhat orthogonal. I think when you talk about protecting the privacy of the data that's being handled by an agent, that's where confidential computing comes into play, which is putting those agents and those LLMs inside of a confidential trust boundary. Especially important, I think, in light of another recent news event, which is Meta conversations being, with their AI agent being leaked publicly. Issues with, for example, OpenAI in a lawsuit they've got, wanting to delete conversation histories, but being told they can't. Confidential computing offers a potential solution to that kind of problem. Speaking of problems with solutions that confidential computing can address, is being able to keep those conversation histories, but ensuring that they're protected with policies that ensure that only the owner of that conversation can get access to them.
Mm-hmm. Nellie, I'd like you to chime in, please.
There are plenty of problems I think we can come up with. Last week, I've been in Gartner conference. It was security and risk management conference. And it was interesting that Gartner was talking about, no surprise, agentic AI. And the questions that they asked me in particular is like what Google is doing about identity and access permissions of those agents, and what particular things we as industry need to come together to figure out how we will separate the agents from humans. It would be nice quality, keeping them, again, authorized, authenticated, and preferably attested, because it's a piece of code, and also understand what and how we will sandbox them to ensure that they will do what exactly we want them to do. So those are the problems that are actually coming to very many conversations that we have with customers as well.
Aaron, what are you hearing on this?
Well, I think that a lot of companies in the enterprise who want to adopt agentic workflows struggle with the proprietary data and having some guarantees about how do we use this with these agentic systems. So confidential AI offers them some very specific guarantees around compliance with their data policies that are enforceable and then auditable after the fact through an immutable log. So there's certainly a lot of applications around AI, but Mark Rusinovich and Mark Papermaster, the CTO of AMD, and the team from Intel have talked a lot about providing guarantees throughout the software development lifecycle and even the hardware supply chain, because confidential capabilities can be applied to attestation of source code as part of the software development lifecycle that would prevent hacks like the infamous SolarWinds that occurred a couple years ago, or ensuring that hardware backdoors aren't inserted into our microchips as part of the supply chain, because you can do attestation of designs before they're manufactured overseas.
Right. I'm the chip reporter, so I've been hearing about these threats for a long time, although I haven't really heard many examples of somebody getting into the cadence files or getting into the foundry to, to actually adjust the chip. It's always been a theoretical problem anyway. But anyone else? Zhao, do you want to throw anything about the problems here?
Well, I think what concerns me the most is that there's just like so many new vectors of attack that I don't think we have fully mapped them out yet. And I think there's going to be more coming up. And these applications, they're interesting because usually one way that you get this overall applications to be more secure is not only establishing boundaries, but then like constantly testing them, right? But this proves to be way easier when you have deterministic systems that you understand how they're going to behave, so you can always test them in a way. And I think with this deterministic systems overall, agentic or not, as soon as you have an LLM in the middle, especially if they're kind of like dictating the flow of the application, you can find yourself on those kind of like the blank is too short kind of situation, where like, well, it used to work, but now I cover my head and my feet are code, and now I cover my feet and my head is code, and how do I fix that? So I think there's an element of like even beyond the environment, but also the development life cycle and how you create the testing capabilities for that to make sure that you ensure on that level that things are doing right as well.
I think Zhao makes a really good point, which is the world needs to understand how to secure something. And I would say if you go back 7 years ago, 8 years ago, when cloud really started to get traction in the enterprise, it was a little bit scary because most large institutions, they understood how to protect something in a data center. They did not understand how to protect something in cloud. Unfortunately, that got figured out via things like cloud security, posture management, and security as code. I think this is wilder now because it's a much bigger quantum. Agentic is a much bigger quantum of change than cloud was, as hard as that may be, which hard to believe, or would have been hard to believe at the time. And the vulnerability I'm most concerned about is agent sprawl, right? We have, potentially massive number of agents in the enterprise, some of which can be quite sophisticated, some of which can be quite simple. We have protocols for agents to talk to agents that don't necessarily have authentication built into them, right? And we don't necessarily know just yet what agentic security looks like or security for agentic applications looks
Exactly.
like. That's going to take time to sort out.
Each agent is another attack surface, right?
Certainly a vulnerability potentially, right? Yeah. And you may have many people creating agents who don't have the discipline or have not been schooled in the discipline of threat modeling and information security.
Yeah. So Zhao, just from the standpoint of your business, since you're dealing with a gazillion of these already, what do you
60 million a month, right? Active?
Yeah. So what are you telling customers about how secure these things are and that kind of thing?
Yeah, I think people are definitely treading carefully. I mean, you can tell that they're trying to cover this basis with like the regular things, right? So I mentioned Department of Defense the other day. In order for us to be able to do business with them, like we got to get like through the FedRAMP high kind of like stamp of approval, that it comes with its own challenges. But honestly, I don't think that's enough to cover some of this vector of attacks that we're talking about. And I think the one thing that I would add, and I was talking with you about this yesterday, is like these agents are operating at not a human speed. They're operating at a machine speed. What makes it even harder, like they can make way more damage.
They talk strange languages.
Exactly. Yeah. So I think right now, like what we're seeing with this company is our most common like customer engagement is completely self-hosted. So starting with that, so they're running this entirely on their system, sometimes completely even on-prem, like on physical servers. A lot of them are looking to self-host in their own models. So I think there's a lot of like, they're looking at it through the lens of data protection right now. I think their thinking is going to evolve a lot throughout this year on like, all right, now the systems are running, especially as we expose them to the outer world, like how we add more safe boundaries in there as well.
Yeah. So another thing that struck me today, listening to Mark and Nelly, is that you guys are spending a lot on this. But I kind of wonder whether people are willing to pay more for it. The average, GCP or Azure customer, do they really want to pay more for this confidential goodness? And if they don't, I mean, how do you recoup your investment here? And maybe you guys could talk about that. Mark, go ahead.
So our goal is to have confidential computing cost the same as non-confidential computing. That's where we.
That's the goal, but you're spending a lot.
Well,
We should pause for applause because someone started the applause.
actually, if you take a look at the confidential hardware that we've got right now, you can deploy it and use it as confidential hardware, or you can deploy it and use it as non-confidential hardware. Some of the things that are leading to higher costs right now, I'll give you a big one, and this impacts all the cloud providers, including Google, is lack of live migration support. Because live migration support would allow us to mix the confidential workloads and VMs on the same hardware as non-confidential, and to be able to defragment rather than have separate pools of capacity. Another one, which is potential concern, is overheads on non-confidential computations from a confidential computation or the configuration on the same hardware. So both of those are being addressed. And once they're addressed, then some of the cost issues go away. But in the meantime, our goal is to charge equivalently for non-confidential and confidential. And this is something we're even doing internally, is to support the migrations that you've seen. Some of these internal workloads don't want to have to pay a higher cost. And so we're motivating them by kind of making deals around, yes, we're going to soak up some more cogs right now, but we're not going to penalize you for it, for migrating onto confidential computing to get more security, so that's not a trade-off you need to consider. Like I said, I think we see a light at the end of the tunnel in the next year or so where these issues go.
Have you seen any difference in the cost pressures from companies in B2B versus B2C markets? Because my impression over time is that consumers are a little bit cheap and cheerful, but people who do business with law firms or group health insurance companies or what have you are fanatical in pressuring their vendors to make sure that they're treating data securely.
Absolutely, and I think, Nellie, I'm sure you're seeing this too, is that what we're seeing right now, given costs, and these costs come not just in terms of potentially the cost for the compute, but costs in terms of complexity, is that the more security sensitive customers are willing to pay that cost to get the benefits of it. There's customers that, and this is what I talk about, it should just be a default, a defense in depth. This on confidential computing, everybody should get that as a default. And until we get the costs, both in terms of the support for availability through things like live migration, as well as the costs of hardware and performance overheads of confidential computing, most people will not be willing to say, yeah, you know what, I want that as a defense in depth, because it's basically free. And we're getting to that. And that's where you just start to unlock everything becomes confidential.
As opposed to some customers being sort of paranoid about it and other customers being a little bit less paranoid.
So Nellie, I'd like you to continue on this.
From my side, first of all, +1 to what Mark said. Again, we have this concept even internally we call coexistence. And its ability for us to run confidential and non-confidential environments on the same hardware to be able to get the proper density, the proper volume. Google, compared to Microsoft, we have a little bit confidential tax, but we're dropping the prices because exactly the same way we believe that it's part of platform part of capability to every single customer that we have. To add to what Mark said, the value that we provide is unblocking very, very sensitive customers coming to the cloud. Because this movement is started, but still we have huge amount of very sensitive workloads, very, again, high value workloads running on-prem. So for those customers to be able to move to the cloud,
so essentially business growth will help pay for the investment.
Exactly. Yeah. And it's why they're adopting GCP and taking advantage of all our services, our platform as a service, infrastructure as a service, and all other services, adopting GCP in masses, in volume. And CC is the enabler of this technology.
I'll give an example of this too, if that's okay. Bloomfilter, who does process mining for software development lifecycle, they're here. They're a user of Opaque to unlock revenue because their downstream customers are concerned about their intellectual property that's being process mined. So for them, it's helping them drive revenue growth through customer acquisition by removing objections as part of the sales cycle. And we're seeing that a lot, particularly in B2B enterprise software too.
Mark, I just wanted to finish one thing about the hardware infrastructure, because I'm the chip guy. What percentage would you say of your servers out there are already upgraded with the proper chips for what we're talking about?
So right now, every server being deployed supports confidential computing.
But the install base?
The install base, I mean, it's going to take some time because these, AMD introduced confidential virtual machine hardware just a couple of years ago. So,
And NVIDIA just more recently, right?
yeah,
Yeah.
NVIDIA GPUs, are very recent. So it's going to take a while to permeate, but it's the permeation starting.
Yeah, right.
Yeah, and just to add on,
Most
go ahead, Nelly.
important
First.
to add to Mark's point, we need to ensure that confidential hardware is available in every single region.
Right.
We have huge demand globally for this capability.
Right.
So we cannot, again, leave customers waiting and expecting that we will bring the capability to them.
Right.
And it will take years.
And a lot of the greatest sensitivities, I imagine, are about
Exactly.
cross-border transfers.
It's
Yeah,
one of
right.
the biggest reasons.
I was just going to say that the confidential GPUs from NVIDIA are, 2.5 years old, guys? Like they're
A year.
fairly,
About a
Here,
Yeah.
yeah, and then they just went live on the cloud providers literally like 6-8 months ago, I think. So within the last 12 months, these have been available through cloud infrastructures. So the point I'm making is that people are becoming increasingly aware of these capabilities and their properties and the benefits of them, but this is all pretty new in order for people to access them, although the underlying technology has been around since Mark and Intel and Jan Stoika at the Berkeley Rise Lab were pioneering it, I guess, 11 years ago, Mark?
Yeah.
10, something like that. So the technology is very mature, but the availability for people who are building applications is pretty recent.
What are the greatest points of friction that are, causing people not to adopt all this as fast as you'd like?
we're trying to eliminate all of those points. And it's, again, one of the biggest things that we focused all the time, in, again, terminologies that Mark proposing, is doing the lift and shift. Don't change your code. Bring it to confidential environments, its own confidential environments, and it's incredibly simple. It's literally checkbox, and whenever you are, your system will become confidential for you. For some customers, and again, as we will be talking about ads and other use cases, they're modifying this capability to have a little more complexity, I guess, for them, but much stronger security protection. Mm-hmm. And depending on where you go to more simpler performance, scale, and usability, or need to have a little more paying for protection, you will find solution on both sides.
Yeah. Aaron, we want to continue that?
Yeah, I think Nelly's spot on, which is I loved Mark's framework for communicating the layers of confidential computing guarantees. He had the on, which is the lift and shift that Nelly just spoke about, the in, where the application's running inside the trusted execution environment, so you have some additional security guarantees. But the real guarantees that's necessary as we look at an agentic web is the transparent confidential computing that Mark had called, that gives you guarantees of agent integrity, immutable audit trail, that everything, your data policies are bound in the runtime and processed while encrypted. To get there, to your question, there's some complexity associated with that, and thankfully there's vendors like Opaque and Cyborg and Anjuna and Edgeless that are here that make it easier for enterprises to adopt this level of confidential guarantees without having to have the entire engineering team of Meta that just built out their Meta private processing for WhatsApp, which is confidential AI, or the stuff that Azure and Google have been doing. It's complex. It requires platform engineering. It requires security engineering, but thankfully there's ISVs, many here at the show, that are making it easier.
Zhao, did you want to add anything on this?
I think honestly it's very interesting. It's definitely a trend, and I think it's going to start with highly regulated industries, but as we get a wider adoption, there's going to be companies like going more in that direction. One thing that I'm noticing as well is there's a new a group of vendors. They're building their own chips, right, and they're trying to be disruptive on that way, and fully appreciate them from that. They get an edge in certain things. Sometimes it's going to be kind of like inference speed is insane, right? But because it's a completely new thing, or sometimes built on top of an old architecture, they're falling behind in some of like the confidential computing kind of like features that is happening in that sense. So I wonder how that's going to play in terms of the adoption for them, and if we're going to get how far along we are from some of this crazy fast inference speeds that we're seeing out there, but running on a completely kind of like confidential computing setting.
James, what about you? When you talk to your customers, what are the things that are causing them to hesitate at all on this?
Hesitate in terms of confidential computing?
Yeah.
I think it's a couple of things. Obviously cost, but even more than that, it's do we even know how to take advantage of it, right? In the what's the model? What do we what do we need to do with the application layer? Given let's face it, in many cases, fairly unsophisticated development teams to take advantage of confidential computing and take advantage of it in the right way. It's both cost efficient and secure and performant.
So being the last thing before lunch and having gone behind schedule, they're contracting our time a little bit. I'm just going to go around and say, when we meet here again next year, hopefully, what are you expecting to see? How's the landscape going to be different, improved, if changed? James, start with you.
I would think, before during my talk, I expressed a little bit of my disappointment that some of the protocols for agent-to-agent communications did not include security, and maybe I'm taking a flyer here and I haven't thought this through, but can we build the use of confidential compute into some of the agentic protocols so that as we have interconnection of more and more agents across more and more enterprises, we have inherent security?
Mark?
So I think two things. One, I'll be able to tell you about more migration internally of Microsoft onto confidential computing.
Right.
I think that we will have a better understanding of agentic security and some of the things like deterministic policy enforcement for information flows that prevent leaks and prevent prompt injections. I think that there'll be a lot of progress on that front, including integration of support for that in MCP and A2A, for example.
Zhao?
For me, it's going to be more about the standards. I mean, I double down on whatever they said, but just to point out a new thing, I think it's very clear that the industry could heavily benefit from standards, and I think right now some companies are looking at standards as a way to kind of get ahead on the business edge. When I think honestly, it should be more about basically up-leveling the entire ecosystem and what that really would look like. So hopefully by next year, the standards are more well-defined, because right now, AI is waiting for nothing. It's not waiting for its own protocols, it's not waiting for its own systems. Just give access to keyboard, mouse, and a browser, and let's go.
It's waiting for GPUs.
So I wonder what that's going to look like a year from now, and I'm hopeful for standards.
Nelly?
I think agentic AI will become something we don't need to define anymore, spell to anybody. People understand, and the security threat and boundaries would be more understood. Again, no spelling needed. I think next year I will continue to, again, ask all of you to think about post-quantum. And nobody will do anything about that.
A lot of us are trying not to think about quantum.
Just to throw another complicated issue right on the table there.
Right there. And saying, okay, it's time for all of us as community to start thinking about what will happen post-quantum will become reality, because it's coming. So I think I will continue to preach, and more people will start taking it seriously.
Aaron, as you're going to be organizing the conference next year, you should have some insights in this.
What I hope we have for everybody next year is, across all of the participants here, we have a standard reference architecture for creating an agentic workflow, meaning that you're chaining it from a zero trust tied to the chip all the way out to an MCP or A2A endpoint, that then you can create a composite system or an agentic system. But we need to come out with a standard reference architecture for that.
Interoperable.
Of course,
Please.
by virtue of it being all of us here, Google, Microsoft, Anthropic, and DeepMind's here. We've got a wide swath of industry. It would have to be interoperable.
I will now lead the panel in Kumbaya. No. No, great. I'll help you. Give thanks to all these guys, and enjoy your lunch.